So good morning everybody, myself Acharya Vishvendra, and today I am here to discuss some of the problems concerned with the photoelectric effect. So the first problem was intensity problem, and intensity problem arise because according to wave theory of light, intensity of light is proportional to the amplitude of electric field, and amplitude of electric field obviously will increase the kmax. So the maximum kinetic energy of electrons should be dependent on the intensity. But experimentally, it was found that maximum kinetic energy was independent of intensity and just dependent on the frequency. So that was the first problem. Second problem was frequency problem. So according to this problem, there should not be the concept of threshold frequency or wavelength. The energy of an electron is uniformly, the energy of a wave is uniformly distributed as per the wave theory. So if a wave of any energy interact with a metal, then after a certain interval of time, the electron should absorb enough energy to come out of the metal, and hence photocurrent should exist, and hence there should not be any concept of threshold frequency or the wavelength as per wave theory is concerned, and light is assumed to be a wave. But it was not happening, as it was found experimentally that if frequency of light is below a certain level, which is called the threshold frequency, then photocurrent is zero. So there was a conflict between theoretical perspectives and the experimental observation. This was the second thing. Third is the time lag problem. So according to the time lag problem, the thing is that if we visualize light as a wave, then it is emitting energy continuously. So if we calculate for an average wavelength, then from the calculations we can show that to absorb energy equivalent to the work function of an average metal, an electron should take at least 2 to 3 hours. That means photoelectric effect should not be instantaneous, but experimentally it was found that photoelectric effect is instantaneous, and as soon as the source of light interacts with the metal surface, electron starts ejecting, and it was found experimentally that the time taken was about 10 is to power minus 9 second or less than that. So that was the third problem, which was not explained using wave theory of light. So these were the three problems. So the intensity problem, the frequency problem, and the time lag problem. Now there was the solutions as given by Sir Albert Einstein, which made him the living legend. So the first thing is that what Albert Einstein proposed, he proposed that light is not a wave, but it is in the form of discrete packets of energy, which he called as the photons or the quantas of light. Now see how things are explained using Albert Einstein's concept. So the first is solutions to the intensity problem. So according to Albert Einstein, light is emitted in terms of discrete particles of energy called as the photons, and at a given time a photon interacts with a specific photon. Either it accepts it or it does not accept it, and it accepts certain photons, and after accepting the photons it gets ejected from the metal surface. So when it gets ejected, it is not present over there, so there is no impact of further increase in intensity of photons or the number of photons. So we can say that due to this, kmax of electrons is just dependent on the intensity or the number of photons. It is independent of the intensity or the number of photons, because a photon will interact only with one electron, or an electron will interact only with one photon at a time, and after that interaction it will come out of the metal or will get transition to some another level. So if we are interested in those electrons which creates the photocurrent, then we can say that an electron will interact with a particular photon and it will absorb it and will come out of the metal crystal. So since it's not absorbing any other photon, so there is no concept of increasing energy or increasing the intensity. So that is how first thing is concerned. And mathematically it can be proved by this equation that if photon interacts with the electron, and suppose the energy of the photon is used as in providing kmax and work function. So from here kmax is h minus phi naught. So there is a direct evidence, mathematical proof that kmax depends on the frequency. So that is the first point. Second is frequency problem. So kmax should be greater than or equal to 0. So from here we can say that nu should be greater than nu naught for photoelectric effect to take place. So that is solution to this. Another is solution to the time lag problem. So according to Albert Einstein, interaction of photon and electron is an instantaneous process. So it's not that it will take some time, it will be instantaneous according to Albert Einstein. So he made this assumption that the interaction is an instantaneous process. So it explains that how photoelectric effect is instantaneous. So in this way Albert Einstein explained all the three problems, all the three issues. So he was able to solve this out, and he this explanation made him the living legend, and he was awarded Nobel Prize for successful explanation of photoelectric effect, and especially the kinetic energy equation involved in the very first process that made him the living legend, and he got the Nobel Prize in 1929, I think, for the explanation of photoelectric effect and contribution in theoretical physics. Thank you and have a nice day.